Good day everybody! Pag-aaralan natin ngayon ay compound interest. So let us begin with a review. And this is entitled, What I Am. Read and analyze. Choose your answers among the principal, simple interest, interest rate, and term. Write your answer on the blank provided for each number. Number 1. I am the blank, which is calculated by multiplying the principal, the rate of interest, and the time in years. The correct answer is simple interest. Number 2. I am the blank, and simple interest is computed based on me and the time in years. The correct answer for number 2 is principal. Number 3. I am the blank. Usually, I am in percent and also called as the rate of increase of interest. The correct answer is interest rate. Last, I am the blank, and I am the length of time between the origin and maturity dates. The correct answer is correct, that is term. Now let us have the formula. Notice that the formula to find the future value in a compound interest is given by future value is equal to principal amount times 1 plus r raised to time or time in years. Now let us have this example. Due to COVID-19 pandemic, Miss Dada, a female resident of Barangay May Pagkakaisa somewhere in Quezon Province, thinks of a business that can provide for her needs as well as the need of her neighbors, so she can be of help even in this trying time. Having no money at hand, she decided to borrow from a bank as the startup capital of 50,000 pesos at 7% interest rate compounded annually and payable within 5 years. Compute for the interest yield. Now let us identify here the given. So the given here are, first we have the principal amount or the starting capital that is equivalent to 50,000, and our interest rate compounded annually is 7%, or if we can have the decimal, we'll have here 0.07, and our time or term is 5 years. Applying this formula, you have our principal amount is 50,000 times 1 plus the interest rate, which is 0.07 raised to the time, which is 5 years. So you have just add 1 plus 0.07 and we'll have 1.07. First, let us multiply 1.07 5 times itself. So 1.07 times 1.07 times 1.07 times 1.07 times 1.07. And we'll have 1.40. Now multiply 50,000 times 1.40. Alright, so we have the product is 70,000. Meaning to say, after 5 years, Miss Dada will pay 70,000. Next, we have given, we have P equals 18,500, R equals 3%, and compoundly annually for 3 years. Find the maturity value or F and the compound interest which is presented by I sub C. Now let us have the solution. Use the formula for maturity value, that is F equals P times 1 plus R raised to T. So you have here, just substitute the given formula. The given is the principal amount, which is 18,500. Then 1 plus 0.03, this is the rate, which is 3%. And the term or time is 3. Came from this one, payable for 3 years. Now let's proceed. Let's perform the operation. 1 plus 0.03 times 1.03 times 1.03 times 18,500, and we'll have 20,215.45 thousandths. This is the maturity value or future value. Now, to find the compound interest, you will just subtract the principal amount from the future value. So remember, our future value is equal to 20,215 and 45 thousandths minus the principal amount, which is 18,500. Let us perform, and you will get 1,715.45 thousand. So this is the compound interest after 3 years, and this 20,215.45 hundredths is the maturity value. Now let us have the given number 2. Given here is the future value, which is equivalent to 15,000. And the rate is 2%, which is compounded annually for 4 years. Now let us find the present value or P. And this is the formula for finding the present value. You have P equals future value all over 1 plus the rate raised to T. Substituting this, so you have 15,000, this is your given future value, and your 2% is expressed here as decimal, that is 0.02. And 4 here came from the time in years. Now let us perform the operation, and you will get 13,857 and 68 hundredths. So that is the present value. Now let us have compounding more than once a year. So in the example above, the interests are compounded annually. However, there are cases that interests are compounded more than once a year. So in this case, additional terms must be clarified, such as the first one is frequency of conversion, or it is represented by a small letter m. This is the number of conversion period in 1 year. Next is the conversion or interest period. This is the time between successive conversions of interest. And then we have total number of conversion periods, which is represented by n. That is equal to the product of frequency of conversion and time in years. And we'll have the nominal rate, or I sub raised to m. This is the annual rate of interest or interest rate per year. And this is the formula. Rate, or represented by J, of interest for each conversion period. So J is equal to I raised to m all over m, or the annual rate of interest all over the frequency of conversion. Now let us study this table. Say for example, the situation is 2% compounded annually for 3 years. So in this given, our m is equal to 1 because that is annually. Alright, and our n, that is m times t. So 1 times 3. 3 came from this one, payable for 3 years. Next, I raised to m, simply the rate. And our rate here is 2%, which is expressed in decimal, that is 0.02. And our j is I raised to m all over m. So our rate is 0.02 divided by 1 is equal to 0.02. Now let us have 2% compounded semi-annually for 3 years. Therefore, our m is equal to 2 because 1 year is divided into 2. And then our n is equal to 2 times 3 equals 6. So again, 2 came from the value of m and 3 came from the time in years. Next is the rate, which is 0.02. And our j is 0.02 divided by 2 equals 0.01. So again, this 2 in our denominator came from the m, okay, which is equal to 2. Now let us have if it's compounded quarterly. So meaning to say, m will be equal to 4. 1 year is divided into 4. And our n is equal to 4 times 3 is equal to 12. Same rate, that is 0.02. And we have 0.02 all over 4 is equal to 0.5 thousandths. Next, what if it's compounded monthly for 3 years? So our m now is equal to 12. Alright, because we have 12 months in a year. And our n is equal to 12 times 3, that is equivalent to 36. Same interest rate, which is 2%, equivalent to 0.02. So we'll have our j is equal to 0.16 ten thousandths. Next, what if it's daily? So remember, in a year, there are 365 days. Therefore, our n here is 365 times 3, that is equal to 1095. Same rate, but our j is 0.02 divided by 365. The quotient is Now let us have compounding more than once a year. This is the formula. So f is equal to p times 1 plus j raised to n. Meanwhile, the formula for finding the present value is given as p is equal to f all over 1 plus j raised to n. Example, given p is equal to 50,000. Our rate is 0.03. Our m is equal to 4. And our term is equal to 4. Find the future value and the compound interest. So, in our given, our term or time in years is 4. It is compounded quarterly. Okay? Using the formula, f is equal to 1 plus j raised to n. And we'll have here n is equal to m times t. So our m again is 4. Came from here. And then our time is equal also to 4. So 4 times 4 is equal to 16. So using the formula, j is equal to I raised to the fourth all over m. Remember, our I or interest is equal to 0.03 all over 4. Next, therefore, our j is equal to 0.0075. That is just the j. Okay, now let us substitute 50,000 times 1 plus 0.0075 raised to the 16th power. So this time, you will just operate what's inside the parentheses. So 1.0075 raised to 16. Then after that, you have to multiply it by 50. And your answer is 56,349.61. So this is the future value. But the other thing we need to find is the compound interest after 4 years. So you have to subtract the principal amount from the future value. Therefore, you have our future value is 56,349.61 minus 50,000. Therefore, our answer is for the compound interest is equal to 6,349.61 hundredths. So our maturity value is 56,349.61 pesos and the compound interest is 6,349.61. Now let us have the last one. We have here the given 45,000. I raised to 2 is equal to 0.02. M is equal to 2 and our T is equal to 4. So this is semi-annual because we have here the exponent 2. But our time in years is 4. Using the formula for finding the present value, you have P is equal to future value divided by 1 plus J raised to N. So same, N is equal to, just multiply M times N. So you have 2 times 4 and our N is equal to 8. And our J is equal to I raised to 2 which is equal to 0.02, that is the interest, all over our m, which is equal to 2. Then just divide 0.02 divided by 2, and you will get 0.01. Now we have the given future value, which is 45,000, and our j, which is equal to 0.01, and our n, which is equal to 8. So our present value is equal to 41,556 and 75 hundredths.